Have you ever wondered why you can never truly touch anything? You are sitting there right now, perhaps holding a phone in your hand, or resting your arms on a wooden desk, or feeling the soft fabric of a chair against your back. It feels solid. It feels real. If you press your finger against a pane of glass, you feel the cool, smooth resistance of the surface. Your brain tells you that your skin is in direct contact with the glass, that there is no space between you and the object you are touching. But this is a beautiful, convincing illusion. It is a lie told to you by your nerves. The truth is far more strange and far more wonderful. The truth is that you are currently hovering. Every part of your body that seems to be touching the world is actually floating on a cushion of invisible force, separated from everything else by a tiny, unbridgeable chasm. You are levitating nanometers above the chair, nanometers away from the floor. You have never touched another human being in your entire life. You have never touched the food you eat or the water you drink. What you interpret as touch is actually a warning signal from the deep structure of the universe. It is the electromagnetic repulsion between the electrons in your skin and the electrons in the object. It is a clash of force fields, a silent scream of subatomic particles refusing to occupy the same space. We live our entire lives believing in solidity, believing in contact. Yet we are ghosts drifting through a world that pushes us away. If you enjoy exploring these quiet mysteries of the cosmos, if you find peace in understanding the fundamental truths that govern our reality, please take a moment to subscribe to the channel. I am Theodore, the researcher, and it is my privilege to be your guide on these journeys into the unknown. By joining our community, you help us continue to ask the big questions, transforming the vast silence of the universe into a place of wonder and discovery. Thank you for being here with us. Now, let us descend into that space between your finger and the glass. Let us shrink down past the ridges of your fingerprints, past the rough landscape of your skin cells, down into the molecular machinery that builds your body. As we go deeper, the noise of the macroscopic world fades away. The chaotic vibrations of heat and sound smooth out into a rhythmic quantum hum. We are entering the realm of the atom. And the first thing you notice here, in this ancient and microscopic kingdom, is the emptiness. We are taught in school that atoms are the building blocks of matter, like tiny Lego bricks stacked together to make a wall. But a Lego brick is solid. An atom is almost entirely void. If you were to take the nucleus of an atom, the heavy, dense heart where the protons and neutrons live, and scale it up to the size of a marble, the rest of the atom would be a cathedral. The electrons would be like tiny dust motes dancing in the furthest corners of the ceiling, hundreds of meters away. Between that marble in the center and those distant dust motes, there is nothing, just empty space. Vast, silent, terrifying empty space. This means that you and I and the earth and the stars are 99.999% empty space. If you could remove all the empty space from the human body, compressing us down to just our actual solid matter, the entire human race, all 8 billion of us, would fit inside the volume of a single sugar cube. That is how ghostly we really are. But if we are mostly emptiness, why do we feel solid? Why does the rock hurt when you kick it? Why does the floor support your weight? The answer lies in that distant, dust mote? The answer lies in the electron. These tiny, shimmering entities are the guardians of the void. They are the architects of volume. They move so fast, whirling around the nucleus at speeds that blur the line between place and motion, that they create a shell of protection. Think of a fan blade spinning at high speed. It looks like a solid disk. If you try to stick your finger through it, you will be struck. The electron is that blade. It creates a cloud of probability, a zone of influence that forbids entry. When your finger approaches the glass, the cloud of electrons in your skin meets the cloud of electrons in the glass, and they push back with the force of the electromagnetic interaction. That push is what you feel as solidity. It is the electrons that give the universe its shape. Without them, matter would collapse into a dense, microscopic dust. They are the reason flowers have color, the reason water is wet, the reason the sun shines. But here is the great mystery, the question that haunts physicists and philosophers alike. We know what the electron does. We know it carries a negative charge. We know it has a specific mass. We have measured its magnetic moment to an accuracy that is equivalent to measuring the distance between New York and Los Angeles to within the width of a human hair. We use electrons every day to power our cities, to calculate our data, to transmit our voices across the world. But for all our mastery, for all our equations and technology, we still do not know what the electron is. If you look at the nucleus of the atom, you find structure. Protons and neutrons are complex little worlds of their own, made of smaller vibrating particles called quarks. You can break a proton apart. You can smash it open and see what is inside. It has a size. It has a radius. It has a chaotic, churning interior. But the electron is different. As far as we can tell, after a century of smashing particles together at nearly the speed of light, the electron has no size. It has no radius. It has no internal structure. In the equations of the standard model of particle physics, the electron is treated as a point particle. Let that sink in for a moment. A point. In geometry, a point is a concept, not an object. It has a position, but it has no dimension. It has no height, no width, no depth. It is a zero-dimensional coordinate. Yet, physics tells us that this mathematical abstraction has mass. It has charge. It has spin. How can something with zero size contain mass? How can something with no volume possess a rotation? If you try to visualize it, your mind might conjure up a tiny, hard sphere, like a microscopic ball bearing. This is how we drew them in high school, little blue dots orbiting the nucleus like planets around a sun. But that image is wrong. If the electron were a sphere with a radius of 0, its density would be infinite. Its charge density would be infinite. It would be a singularity, a tiny black hole of electromagnetism. The math breaks down. The intuition fails. We are faced with an object that is undeniably real. It hits screens. It flows through wires. It crashes into detectors. Yet it seems to lack the most basic property of existence: spatial extent. This paradox draws us into a journey of profound wonder. We are about to embark on an expedition, not to the edge of the universe, but to the center of reality. We are going to ask the forbidden question: what is hidden inside an electron? If we could zoom in past the cloud, past the orbital dance, past the barrier of the Heisenberg uncertainty principle, what would we find at the core? Is there a tiny clockwork mechanism ticking away? Is there a vibrating string of pure energy? Is there a portal to another dimension? Or is there truly, fundamentally nothing, a knot in the fabric of space itself? This journey will take us from the Victorian laboratories, where the electron was first glimpsed as a corpuscle, to the frozen tunnels of modern particle colliders, and finally to the edge of theoretical physics, where measurement ends and philosophy begins. We must approach this with humility. The electron is ancient. Every electron in your body is as old as the universe itself, forged in the first moments of the Big Bang. They have witnessed the birth of stars and the death of galaxies. They have traveled through the interstellar void for billions of years before coming to rest for a brief moment in the atoms of your fingertips. They are eternal travelers, carrying the secrets of creation in their massless hearts. And yet, they are gentle. They bind atoms together into molecules, allowing the complexity of life to emerge from the chaos of raw matter. They are the glue of the cosmos, soft and yielding in their orbits, yet hard and unyielding in their identity. They are all identical. Every electron is exactly the same as every other electron. If you swapped an electron from a star in the Andromeda galaxy with an electron in your own brain, nothing would change. They are perfect copies, indistinguishable, suggesting a deep, underlying unity to all things. As we stand here at the threshold of this investigation, I want you to feel the weight of this mystery. Look at your hand again. It is a galaxy of atoms. It is a swarm of point particles. It is a vast cathedral of empty space, held together by the frantic motion of ghosts. The solidity you feel is a mirage. The reality is a dance of fields and forces, a shimmering interplay of energy and void. We are made of mysteries. We are walking paradoxes, composed of things that have no size, yet give us our size. We are built of entities that have no surface, yet give us our surface. To understand the electron is to understand the fundamental contradiction at the heart of existence. How something can come from nothing. How the tangible can be built from the intangible. In the chapters that follow, we will peel back the layers of this enigma. We will look at the electron not just as a variable in an equation, but as a protagonist in the story of the universe. We will explore the strange reality of spin, a rotation that is not a rotation. We will dive into the concept of the virtual cloud, the swarm of phantom particles that surrounds every electron like a cloak. We will ask if the electron is actually a single measurement of a field that stretches across the entire universe, making every electron just a different peak of the same ocean. And we will confront the possibility that space and time themselves might dissolve at these scales, revealing a deeper geometry that we are only just beginning to imagine. The journey inward is just as vast as the journey outward. The distance between the electron and the nucleus, relative to their size, is as great as the distance between the Earth and the Sun. There are worlds within worlds, silence within silence. So, take a deep breath. Let the noise of the day fall away. Let your mind settle into the quiet rhythm of curiosity. We are going to shrink down. We are going to pass through the veil of the familiar. We are going to try to touch the untouchable. The core of the electron awaits us, hiding its secrets in a point of infinite smallness. What we find there might change how you see everything, from the stars in the night sky to the very thoughts moving through your mind right now. Welcome to the journey. To understand the ghost in the machine, we must travel back to a time when the machine was made of brass, mahogany, and hand-blown glass. We must leave the sterile, subterranean tunnels of modern particle colliders and step into the flickering gaslight of the late 19th century. Picture a rainy evening in Cambridge, England, in the year 1897. We are entering the Cavendish Laboratory, a place of heavy oak doors and echoing corridors where the air smells of ozone and damp wool. Here, in a room filled with the hum of primitive batteries and the scratching of fountain pens on parchment, a quiet revolution is taking place. It is a revolution that will not topple kings or redraw maps, but it will shatter the very foundation of reality as humanity understands it. Standing at a wooden bench, peering intently at a glowing glass tube, is a man named Joseph John Thomson. He is about to look into the heart of matter and find something that should not exist. He is about to discover the electron. At this moment in history, the atom is still considered the ultimate indivisible unit of nature. The word itself, atom, comes from the ancient Greek atomos, meaning uncuttable. For thousands of years, philosophers and scientists believed that if you took a piece of gold and cut it in half, and then cut that half in half, and kept going, you would eventually reach a tiny, hard grain of gold that could not be divided any further. These atoms were thought to be solid, eternal, and immutable, the billiard balls of the cosmos. But Thomson is looking at something that defies this ancient logic. He is experimenting with a device called a cathode ray tube. It is a simple instrument by today's standards, a sealed glass vessel from which almost all the air has been removed, creating a vacuum. At one end, there is a metal plate connected to a negative electrical terminal, the cathode. At the other end, a positive terminal, the anode. When a high voltage is applied, something strange happens. A ghostly, invisible beam streams from the negative plate, flying through the vacuum. When this beam hits the glass at the far end of the tube, it creates an eerie, spectral green glow. For decades, scientists had argued over what these cathode rays actually were. Many believed they were waves, ripples in the mysterious ether that was thought to fill all of space. Others thought they might be a new state of matter. But Thomson suspects something far more radical. He places magnets around the tube. He places electrically charged plates inside the tube. He watches the green glow with the intensity of a hawk. He sees the beam bend. It curves away from the negative plate and towards the positive plate. It curves when it passes through a magnetic field. Waves do not bend like this. Light does not bend like this under normal circumstances. Thomson realizes with a shiver that must have run down his spine that he is not looking at rays of light. He is looking at a stream of particles. He is looking at pieces of matter that are flying through the void. But the true shock comes when he measures them. By carefully balancing the magnetic and electric fields, balancing the forces that push and pull the beam, Thomson is able to calculate the ratio of these particles' mass to their electric charge. The number he gets is impossible. It is staggering. These particles are roughly 2,000 times lighter than the lightest atom known to science, the hydrogen atom. This is a moment of profound cognitive dissonance. If atoms are the smallest possible things, how can there be something 2,000 times smaller? The only conclusion, the heresy that Thomson dares to publish, is that the atom is not indivisible. The atom has parts. It can be broken. And these tiny particles, these corpuscles, as he calls them, are the chips that have been struck off the block. He has found the first subatomic particle. He has discovered the electron. Imagine the silence in that room as the implication settles in. For all of human history, matter was thought to be continuous and solid. Now, suddenly, it is revealed to be a cage for these tiny, frantic entities. Thomson imagines the atom as a plum pudding, a positively charged sphere of nebulous fluid with these tiny negative corpuscles embedded inside like raisins in a dessert. It is a quaint Victorian model, and we now know it to be wrong, but it represents the first time humanity realized that reality has a hidden architecture. We realize that the solid world is a facade. Behind the wood of the desk, behind the glass of the tube, behind the skin of Thomson's own hand, there are swarms of these infinitesimally small things, buzzing with electric potential. But this discovery, monumental as it was, only deepened the mystery. Thomson had weighed the electron. He had measured its charge, but he had not seen it. No one has ever seen an electron. We see the green glow it causes when it crashes into phosphor. We see the trail of bubbles it leaves in a detection chamber. We see the spark it creates when it jumps a gap. But the thing itself remains hidden. It is like seeing footprints in the snow, but never seeing the walker. You know something was there. You know how heavy it was, how fast it was moving, but you do not know what it looked like. You do not know its face. As the 20th century dawned, the mystery of the electron's nature began to unravel the very fabric of classical physics. Scientists tried to apply the old rules to this new particle, but the rules refused to work. If the electron was a tiny ball of charged matter orbiting a nucleus, as the later Rutherford model suggested, it should be constantly emitting radiation. According to the laws of electromagnetism, a charged particle moving in a circle loses energy. It radiates light. This means that every electron in the universe should spiral inwards, crashing into the nucleus in a fraction of a second. Every atom in existence should collapse instantly. You should not be here. The Earth should not be here. The universe should have destroyed itself in a flash of light billions of years ago. But the universe did not collapse. The atoms stayed stable. The electrons refused to fall. They stayed in their orbits, defying the laws of classical mechanics, humming in their silent, stubborn shells. This impossibility forced humanity to invent a new language to describe reality: quantum mechanics. We had to accept that the electron is not a little ball. It is not a planet orbiting a sun. It is something far more subtle and far more strange. It is a standing wave. It is a cloud of probability. It is a ghost that can be in two places at once, a spirit that occupies a volume without filling it. Let us pause and consider the scale of what Thomson found. To say the electron is small is to say the sun is hot. It is a truth so vast it becomes almost meaningless. Let us try to visualize it. If you were to magnify an atom until it was the size of the dome of St. Peter's Basilica in Rome, the nucleus would be a small grain of salt suspended in the center of the vast open air. The electrons, they would be invisible specks, smaller than dust, whirling around the outer edges of the dome. And yet, these invisible specks determine everything about the atom. They determine how it bonds with other atoms. They determine if it is a metal or a gas, if it is toxic or nutritious, if it is blue or red. The heavy nucleus in the center is just the anchor, the gravitational weight. The electrons are the personality. They are the face the atom shows to the world. Everything you have ever experienced, every color you have seen, every texture you have felt, every chemical reaction that keeps your heart beating, is an interaction between these tiny, invisible raisins in the cosmic pudding. But the question remains, what are they? Thomson found a particle with mass and charge. Later experiments found that this particle has a spin, a property that makes it act like a tiny magnet. But when we try to find the body of the electron, the physical substance that holds this mass and charge and spin, we find nothing. We can smash electrons together at velocities approaching the speed of light, and they do not break. They do not scatter like billiard balls. They do not reveal internal gears or springs. They appear to be true mathematical points. This brings us back to the central paradox of our journey. How can a point have properties? Imagine a spinning top. It has mass. It has a shape. It spins because its physical material is rotating around an axis. Now, imagine shrinking that top. It gets smaller and smaller. Eventually, it becomes a dot with zero size. How can it still spin? What is moving? If nothing is extending in space, how can it rotate? Yet, the electron has spin. It has angular momentum. It acts exactly as if it were a spinning sphere, but we know it cannot be a sphere. If it were a sphere small enough to fit the experimental limits, it would have to spin faster than the speed of light at its equator to generate the magnetic field we observe. And Einstein has told us that nothing can move faster than light. So we are left with a ghost, a corpuscle that is not a body, but a bundle of properties held together by a mathematical rule. In the glowing green light of Thomson's tube, we caught a glimpse of the universe's shadow. We found the thing that carries the spark of life, the thing that flows through our nerves and powers our thoughts. But in finding it, we lost our understanding of what it means to be a thing. We traded the solid, comforting certainty of the billiard ball atom for a reality of probability and paradox. The electron is the gatekeeper of the quantum world, standing at the threshold between the human scale and the impossible scale. It invites us to leave our intuition at the door. Thomson himself, in his later years, marveled at the new world he had uncovered. He had opened a door that could never be closed. He had shown that the universe was not made of static, dead matter, but of dynamic, energetic entities. The air in that Cambridge laboratory, once thought to be just empty space or ether, was now known to be alive with these subatomic dancers. And as we moved from the gaslight era into the atomic age, the mystery of the electron only deepened. We built better machines. We developed better theories. We map the electron's behavior with exquisite precision. We know where it will be, statistically. We know what it will do, probabilistically. But the question of what it is, what lies inside that point-like heart, remains as opaque today as it was in 1897. As we end this chapter, I want you to visualize that green glow again. It is the color of discovery. It is the color of the unknown. That faint, eerie light in the glass tube was the first signal from the quantum realm, a lighthouse beam warning us that the ocean of reality is far deeper and stranger than we ever imagined. We have named the particle, we have harnessed it, but we have not tamed it. It remains wild, a tiny singularity of mass and charge, drifting through the cathedral of the atom. In the next chapter, we will try to look closer. We will try to understand how this point particle manages to take up space, how it creates the illusion of size without having any size of its own. We will explore the cloud, the wave, and the dance. We will ask, if the electron is a point, why can't we crush matter down to nothing? The answer lies in the loneliness of the electron, a social distancing rule written into the fabric of the cosmos that keeps the universe from collapsing. But for now, let us rest in the wonder of that first discovery, the realization that the world is more complex, more fragile, and more beautiful than it appears, the realization that we are surrounded by and composed of billions upon billions of tiny ghosts, all humming the same silent tune. If the electron is a ghost, a tiny point of nothingness with no size and no surface, then we are faced with a terrifying question. Why does the universe not simply fall through itself? If you are made of atoms, and atoms are 99.9% empty space, and the electrons that patrol that space are infinitely small points, then you're essentially a phantom. You should be able to walk through walls. You should be able to slip through the floor. The earth should collapse under its own gravity, shrinking down until all those tiny points touch each other, reducing our entire planet to a sphere the size of a football field. But this does not happen. You are here. You are solid. The ground holds you. The walls stop you. The answer to this mystery lies in a rule so absolute, so fundamental, that it dictates the structure of everything from the DNA in your cells to the neutron stars burning at the edge of the galaxy. It is a rule of profound loneliness. It is the story of why the electron refuses to share its space. We often imagine the atom as a miniature solar system, a peaceful clockwork model where electrons orbit the nucleus like obedient planets. This is the image stamped on science textbooks and nuclear energy logos. It is a comforting image because it is familiar. We understand gravity. We understand orbits. But the quantum world is not a solar system. It is a chaotic, shimmering storm. If you could shrink down and enter the atom, you would not see a little blue ball tracing a neat circle. You would see a frantic, vibrating haze. This is the electron cloud. But do not let the word cloud fool you. It is not a cloud of gas or mist. It is a cloud of probability. The electron is still a single point, but it moves with such manic energy, with such desperate speed, that it appears to be everywhere at once. Imagine a firefly trapped in a glass jar. If the firefly sits still, you see a single point of light. But if the firefly flies fast enough, frantically darting from wall to wall in a fraction of a second, your eye would see a glowing jar, a solid volume of light. The electron is that firefly. It creates the illusion of solidity through the sheer ferocity of its motion. Before we dive deeper into this quantum storm, into the rules that keep the universe from collapsing, I would like to invite you to join our community of curious minds. If these journeys into the heart of matter bring you a sense of wonder, please subscribe to the channel and leave a like. I am Theodore, the researcher, and it is my goal to transform these complex scientific truths into a quiet space for contemplation. Your support helps us keep exploring the cosmos, one mystery at a time. Thank you. Now, why does the firefly move so fast? Why doesn't it just settle down and rest on the nucleus? The answer is the first great law of the quantum realm, the Heisenberg uncertainty principle. This law tells us that nature has a built-in fuzziness. You cannot know both the position and the speed of an electron with perfect precision. The more you try to pin it down to a specific location, the more wildly its speed fluctuates. If you try to squeeze an electron into a tiny space like the nucleus, its velocity explodes. It begins to vibrate with infinite energy, fighting against the confinement. The electron is claustrophobic. It needs room to breathe. This need for uncertainty forces it to stay away from the nucleus, to spread out, to occupy a vast volume of space relative to its size. It creates the shell of the atom, not because it has a hard surface, but because it refuses to be pinned down. But there is a second law, even more powerful than the first, that gives matter its true strength. It is called the Pauli exclusion principle. Discovered by the Austrian physicist Wolfgang Pauli in 1925, this rule is the ultimate social distancing law of the universe. It states quite simply that no two electrons can occupy the same quantum state at the same time. They cannot be in the same place, with the same energy and the same spin. They are fermions, the individualists of the particle world. They demand uniqueness. Imagine a concert hall where every seat is a specific quantum state. Once an electron takes a seat, say, the row A, seat 1, spin-up seat, no other electron in the universe can sit there. If another electron comes along, it is forced to take a different seat, perhaps in a higher row with higher energy. This seems like a simple bureaucratic rule, a bit of cosmic bookkeeping, but its consequences are violent and structural. Because electrons refuse to stack on top of each other, they are forced to build outwards. When you add more electrons to an atom, they cannot just crowd into the lowest, most comfortable orbit, near the nucleus. That space is taken. They must move to higher and higher shells, further and further out. This is what gives atoms their size. This is what creates the periodic table of elements. Carbon behaves differently than oxygen because its electrons are forced into different seating arrangements. The exclusion principle is the architect of chemistry. It is the reason water is water and stone is stone. But its power goes beyond just structure. It is the source of the touch we discussed in the beginning. When you press your hand against a table, it is not just the electric charge repelling you. It is the Pauli exclusion principle asserting itself. The electrons in your hand are saying to the electrons in the table, "This quantum state is taken. You cannot be here." The resistance you feel is the universe protecting the individuality of its particles. If this rule were to turn off for even a single second, all the electrons in your body would crash down into the lowest possible energy state. you would instantly collapse. The table would collapse. The entire world would implode into a dense, energetic soup. Matter as we know it, structured, voluminous, complex, would cease to exist. This resistance is so strong that it can even hold up stars. When a sun-like star dies, it runs out of fuel and begins to collapse under its own gravity. The crushing weight of the star tries to squeeze the atoms together, but the electrons fight back. They are pushed closer and closer until they run out of empty seats. They are packed as tightly as the laws of physics allow. At this point, a new kind of pressure emerges, not from heat, but from the sheer refusal of electrons to occupy the same space. It is called electron degeneracy pressure. This quantum stubbornness is strong enough to halt the collapse of a star, creating a white dwarf. A white dwarf is a diamond the size of the Earth, a stellar corpse, held up entirely by the Pauli exclusion principle. It is a monument to the electron's desire for solitude. So, the electron is a paradox wrapped in a mystery. It is a point with no size, yet it creates the volume of the atom. It is a ghost that cannot be touched, yet it is the reason we can touch anything. It is a frantic, claustrophobic entity that creates stability through its refusal to be confined. As we look deeper into this cloud, we realize that solidity is not a property of the stuff itself. The stuff, the point particle, is vanishingly small. Solidity is a property of the rules. It is the laws of quantum mechanics, uncertainty and exclusion, that act like invisible scaffolding, inflating the void into the world we see. But what happens if we look even closer? We have described the electron as a cloud, a wave, a point. But modern physics suggests it might be something even stranger. We have to talk about the field. In our journey to the core, we must discard the idea of the particle entirely. Imagine the universe not as a collection of objects, but as a collection of fluids, invisible, trembling fluids that fill every corner of space and time. These are the quantum fields. There is an electron field that stretches from one end of the cosmos to the other. It is everywhere. It is inside you. It is inside the vacuum of space. It is inside the black hole. What we call an electron, that little point we have been chasing, is just a ripple in this field. It is a wave cresting in the ocean. This brings us to a vertigo-inducing realization. If the electron is just a ripple in a field, does it have an inside? Does a wave in the ocean have an inside? Or is it just energy moving through a medium? When we ask what is hidden in the core of an electron, we might be asking the wrong question. We might be looking for a pit inside a peach, when the electron is actually a knot in a rope. The core might not be a physical center, but a mathematical singularity where the field reaches a critical intensity. And yet, the mystery of the point persists. Even in quantum field theory, the electron is treated as a point-like excitation. If you pour enough energy into the field, you get a particle. But why this particle? Why this specific mass? Why this specific charge? Why does the electron weigh exactly 511 mega-electron volts? Why is it not heavier? Why is it not lighter? If it were slightly heavier, the neutron would decay faster, and the universe would be full of hydrogen but nothing else. No carbon, no oxygen, no life. If it were lighter, the proton would capture it too easily, and atoms would be unstable. The electron seems perfectly tuned for our existence. It sits in the Goldilocks zone of particle physics, heavy enough to hold its ground, light enough to form the delicate bonds of chemistry. Is there a reason for these numbers? Or are they random accidents? Some physicists believe that inside the electron, hidden in that point of zero size, lie extra dimensions of space. String theory suggests that the electron is not a point at all, but a tiny loop of vibrating string. The mass and charge we measure are just the notes that this string is playing. If the string vibrates one way, it looks like an electron. If it vibrates another way, it looks like a quark. According to this theory, the core of the electron is a gateway to a six-dimensional geometry that is curled up so tightly we cannot see it. We are walking through a universe of 10 or 11 dimensions, but we are trapped in 3. The electron might be the key to unlocking those hidden realms. As we stand in the midst of this quantum storm, surrounded by the exclusion zones and the uncertainty clouds, we feel a sense of awe. The mundane world, the chair, the table, the glass, is revealed to be a magnificent illusion sustained by the frantic, lonely dance of billions of ghosts. They are pushing against each other, fighting for their right to exist in their own unique state. And in that struggle, they create the structure of reality. The silence of the atom is not empty. It is tense. It is filled with the pressure of existence asserting itself against the void. In the next chapter, we will take a step further into the abstract. We will explore the virtual cloud. We will learn that the electron is never truly alone. It is surrounded by a swarm of phantom particles that pop in and out of existence, an entourage of short-lived ghosts that cling to it, like moths to a flame. We will ask if the electron we measure is the real electron, or if we are only ever seeing its disguise. We will peel back the cloak of the vacuum to see the naked charge beneath, and find that the closer we look, the more the universe tries to hide. For now, let the idea of the exclusion principle settle in your mind. Feel the chair beneath you. Feel the resistance. That is the sound of billions of electrons shouting, "I am here, and I am unique." You are supported by a chorus of subatomic voices, a choir of fermions singing the song of solidity. You're not touching the world. You're interacting with its field. You are a wave washing against another wave in the great ocean of the cosmos. If you look at a diamond, you see a single, static object. It sits there, cold and hard, reflecting the light. But if you were to look at that diamond through the lens of quantum electrodynamics, the most precise theory humanity has ever devised, the gem would vanish. In its place, you would see a seething, boiling ocean of energy. The static electrons inside the carbon atoms would be revealed as the epicenters of a violent storm. We are now entering the strangest part of our journey to the core. We are going to discover that the electron is not just a loner floating in the void. It is a celebrity moving through a crowd. It is surrounded by an entourage of phantom particles that cling to it, shielding it, disguising it, and fundamentally altering its nature. To understand what is hidden in the core, we must first peel away this cloak. We must understand the virtual cloud. We have been taught to think of empty space as a vacuum, a nothingness where no matter exists. But in the quantum world, there is no such thing as nothing. The vacuum is not empty. It is merely balanced. It is a reservoir of infinite potential, a dormant sea of energy waiting to be disturbed. According to the laws of quantum mechanics, specifically the time-energy uncertainty principle, the universe is allowed to borrow energy from nowhere, as long as it pays it back very quickly. This sounds like a violation of the laws of physics, a cosmic embezzlement scheme. But it is happening right now, in the space between your eyes and this screen. In every cubic centimeter of the universe, billions of particle pairs are popping into existence and then annihilating each other in a fraction of a nanosecond. Matter and antimatter, created from the void, destroying each other and returning to the void. This is the quantum foam. It is the background hum of reality. Usually this foam is invisible to us. It averages out to zero. But when you introduce an electron into this foam, everything changes. The electron carries an electric charge. It is a source of influence. It is like dropping a heavy stone into a still pond, or more accurately, like placing a powerful magnet into a pile of iron filings. The presence of the electron disturbs the vacuum. It pulls on the phantom particles hidden in the foam. Specifically, the electron's negative charge acts as a siren song to the virtual positrons living in the vacuum. A positron is the antimatter twin of the electron. It has the same mass, but a positive charge. When the electron moves through space, it drags a cloud of these virtual positrons around it. They swarm towards it, attracted by its negative charge. At the same time, the virtual electrons in the vacuum are repelled, pushed away. This creates a structure. The real electron at the center is surrounded by a dense, shimmering screen of positive charge from the virtual positrons. This is called vacuum polarization. It is a shield. It is a disguise. And it means that we have never, ever seen a naked electron. Think about what this means for a moment. Every measurement we have ever made of an electron's charge is actually a measurement of the electron plus its cloud. We are measuring the dressed electron. The positive swarm of positrons cancels out some of the electron's negative charge, making it appear weaker than it actually is. It is like looking at a bright light bulb through a thick, frosted glass sphere. The light, you see, is soft and diffuse. But if you could break the glass, if you could peel away the layer of virtual particles, the light would be blinding. Physicists have actually tested this. They have smashed particles together at higher and higher energies, which is effectively like getting closer and closer to the core of the electron. When you penetrate deeper into the cloud, past the outer layers of the positron shield, you start to see more of the naked charge. The electric force gets stronger. The closer you look, the more powerful the electron becomes. This is a terrifying realization. It implies that if you could reach the absolute center, the mathematical point we discussed earlier, the charge of the electron might be infinite. It implies that at its heart, the electron is a singularity of infinite energy, a monster that is only tamed by the blanket of the vacuum. This problem, the problem of infinities, almost destroyed physics in the mid-20th century, when scientists first tried to calculate the mass and charge of the electron using quantum equations. The answers kept coming back as infinity. The equations were saying that a single electron should have more mass than the entire universe. It was a catastrophe. It seemed that our theory of reality was fundamentally broken. It took the genius of Richard Feynman, Julian Schwinger, and Shinichiro Tomonaga to solve this. They developed a mathematical trick called renormalization. It is a complex process, but in essence, it involves accepting that we can never see the naked core. We simply redefine the mass and charge of the electron to be the measured values, the dressed values, and we ignore the infinite core. We draw a curtain around the singularity and agree only to talk about what is outside the curtain. Feynman himself called this process a dippy process, a kind of sweeping of the dust under the rug. But it works. Quantum electrodynamics, or QED, is the theory that emerged from this crisis, and it is the most successful theory in the history of science. It predicts the magnetic moment of the electron to 12 decimal places, matching experiments exactly. It is like predicting the distance from New York to Paris to within the width of a human hair. But the philosophical scar remains. We have a theory that works perfectly, yet it is built on the assumption that we must ignore the infinite monster hiding in the center. So, when we ask what is hidden in the core, the answer from QED is a paradox. The core is a point of infinite potential that generates a cloud of virtual particles, and it is the cloud that we interact with. The electron is not just the seed, it is the flower. It is a composite entity made of a real particle and a virtual entourage. This blurs the line between the particle and the universe. Where does the electron end and the vacuum begin? The cloud fades out gradually, getting thinner and thinner, but technically it extends forever. The electric field of a single electron touches every other particle in the cosmos. In a poetic sense, the electron is a knot tied in the fabric of the vacuum, a localized storm in the infinite ocean. This view of the electron helps us understand why it is so stable. You might wonder, if the electron is surrounded by all this chaotic energy, why doesn't it fall apart? Why doesn't it decay into lighter particles? The answer is that there are no lighter particles with an electric charge. The electron is the smallest, lightest carrier of negative charge in the universe. It is the ground floor of the charged world. It has nowhere to go. It is trapped in its existence by the laws of conservation. It is an island of stability in the quantum foam. But let us go back to the image of the virtual particles. These are not just mathematical abstractions. They have real effects. There is a phenomenon called the Lamb shift, a tiny change in the energy levels of the hydrogen atom, which is caused entirely by the interaction of the electron with its own virtual cloud. The electron is constantly talking to the vacuum, emitting and reabsorbing virtual photons. It is a conversation that never stops. Even when an electron is sitting perfectly still in deep space, miles from any other matter, it is buzzing with activity. It is juggling photons. It is wrestling with positrons. It is a dynamo of self-interaction. This realization that the empty space around the core is actually full of activity changes how we visualize the touch we spoke of in the first chapter. When two electrons repel each other, they are not just pushing against each other's fields like two magnets. They are exchanging virtual photons. They are throwing particles of light back and forth like two ice skaters throwing heavy medicine balls at each other. The act of throwing the ball pushes the thrower back. the act of catching it, pushes the catcher back. This exchange of virtual force carriers is what creates the repulsion. The force is actually a stream of particles. The electron is a machine that constantly manufactures and absorbs these messengers of light. And here we find another layer of the mystery. The electron interacts with the electromagnetic field because it has charge. But where does the charge come from? Is it painted onto the surface of the point particle? Is it a property of the space inside the point? Modern theories suggest that charge is not a substance, but a relationship. It is a measure of how strongly the particle couples to the field. To have a charge of 1 is to have a specific key that unlocks the door to the photon field. The core of the electron is the keeper of this key. As we descend through these layers, the probability cloud of the atom, the virtual particle cloud of the vacuum, the screen of positrons, we are getting closer to the naked truth. But the universe seems determined to prevent us from seeing it. It wraps the electron in veil after veil. It hides the singularity behind a wall of quantum fluctuations. It is as if nature is protecting us from the raw intensity of the core. If we could see the naked electron, perhaps its infinite charge would rip the fabric of space-time apart. Perhaps the renormalization is not just a mathematical trick, but a description of how the universe heals itself, how it covers up its singularities with a bandage of virtual matter to keep the cosmos safe for life. There is a beautiful melancholy in this. The electron is the ultimate connector. It binds atoms, it conducts electricity, it creates chemistry. Yet it is wrapped in a cocoon of isolation. It is always separated from the world by its own shield. It carries its own atmosphere wherever it goes. And this atmosphere is made of borrowed existence, of particles that live on the edge of reality, existing only long enough to hide the true face of their master. We are investigating a phantom. We have peeled back the solid shell of the atom to find empty space. We have peeled back the cloud of the orbit to find a point. Now we have peeled back the point to find a storm of virtual particles. What is left? If we could stop the storm, if we could quiet the vacuum, if we could strip away the dress, what would remain? Would there be a tiny, vibrating grain of sand? Or would there be a geometry of higher dimensions? In the next chapter, we will confront the most mind-bending possibility of all. We will ask if the electron is actually a tiny black hole. We will look at the Schwarzschild radius of an electron and ask if gravity, the force we usually ignore in the quantum world, might actually be the secret ingredient that holds the particle together. We will explore the idea of the Geon, a gravitational electromagnetic entity, and we will stand on the precipice of the Planck scale, the smallest possible distance in the universe, where space and time themselves lose their meaning. For now, I want you to sit with the knowledge that the space around you is not empty. It is a frantic, boiling ocean. And every electron in your body is a tiny island in that ocean, constantly shaping and being shaped by the waves of the invisible. You're not made of static bricks. You're made of storms. You're a collection of infinite potentials, dressed in the disguise of finite matter. In our quest to find the heart of the electron, we have looked at it through the lens of electricity, magnetism, and quantum probability. But there is one force we have ignored. It is the oldest force, the most familiar force, and yet the most mysterious force of all. Gravity. We tend to think of gravity as the ruler of the large, the force that shapes galaxies, binds solar systems, and keeps our feet planted on the ground. In the subatomic world, we are told that gravity is negligible. It is so weak compared to the electromagnetic force, about 1,000 billion times weaker, that physicists usually throw it out of their equations entirely. To an electron, the electric pull of the nucleus is a roaring hurricane, while the gravitational pull is less than a whisper. But we are not interested in the usual equations today. We are interested in the extreme. We are interested in the singularity. And when you squeeze any amount of mass, no matter how small, into a point of zero size, gravity suddenly becomes the most important thing in the universe. We must ask the question that sounds like the plot of a science fiction novel, but is actually a serious subject of theoretical physics. Is the electron actually a microscopic black hole? According to Albert Einstein's general relativity, gravity is not a force, but a curvature of space and time. Mass tells space how to curve, and space tells mass how to move. If you take the Earth and squeeze it down to the size of a peanut, the curvature of space around it would become so steep that nothing, not even light, could escape. It would become a black hole. Now, look at the electron. We have established that experiments show it to be a point particle. It has a mass, a tiny mass, about 9.1 times 10 to the power of negative 31 kilograms. But it is confined within a radius that is effectively zero. In mathematics, if you divide any number by zero, you get infinity. If the electron truly has zero radius, its density is infinite. Its space-time curvature is infinite. By the strict definitions of Einstein's theory, every single electron in your body should be a black hole. You should be made of billions of trillions of tiny, hungry singularities, each one tearing at the fabric of space. Before we explore why you are not currently being devoured by your own atoms, I would like to gently remind you that this channel exists to explore these deep, sometimes vertiginous questions together. If you appreciate this blend of hard science and quiet contemplation, please subscribe to Theodore, the researcher. Your presence here helps us build a sanctuary for curiosity in a noisy world. Thank you for walking this path with us. So, why isn't the electron a black hole in the traditional sense? To understand this, we have to look at the numbers, and the numbers lead us to a place where physics itself begins to crumble. There is a formula called the Schwarzschild radius, which tells us how small an object needs to be to become a black hole. If we plug the mass of the electron into this formula, we get a size of approximately 10 to the power of negative 57 meters. This is an unimaginably small number. To put it in perspective, the difference between this size and a standard atom is roughly the same as the difference between a grain of sand and the entire observable universe. It is a scale so deep that it makes the nucleus look like a galaxy. But here is the problem. There is a limit to how small things can get in our current understanding of the universe. It is called the Planck length, and it sits at about 10 to the power of negative 35 meters. The Planck length is the pixel size of the cosmos. Below this scale, the concepts of distance and geometry lose their meaning. Space becomes a foaming, chaotic mess where up and down, before and after, no longer exist. The calculated black hole size of the electron is trillions of times smaller than the Planck length. This means the electron is hiding in a realm that physics cannot reach. It is subpixel. It exists in the cracks of reality. If the electron is a black hole, it is a black hole that is too small to exist according to the rules of quantum mechanics. This is the great clash. General relativity says the electron must be a black hole because of its density. Quantum mechanics says it cannot be a black hole because it is smaller than the smallest possible thing. However, the story gets even stranger when we remember that the electron is not just mass. It is also charge, and it is also spin. In the world of black holes, these properties change the shape of the event horizon. A simple, non-spinning, neutral black hole has a spherical horizon, but a charged spinning black hole, described by something called the Kerr-Newman metric, is different. It has two horizons, an inner one and an outer one. Between them lies a zone of chaos. But here is the critical twist. For a black hole to maintain an event horizon, the surface of darkness that hides the singularity, there must be a balance. The gravity pulling in must be strong enough to overcome the forces pushing out. For the electron, this balance is completely broken. The electron's electric charge is enormous compared to its mass. The repulsive force of the charge, the desire of the electricity to explode outwards, is roughly 10 to the power of 42 times stronger than the gravitational force pulling in. This is a number with 42 zeros. It is a dominance so total that it shatters the event horizon. In the equations of general relativity, if the charge and spin are too high relative to the mass, the horizons vanish. They are blown away. What is left is something called a naked singularity. A naked singularity is a nightmare for physicists. A normal black hole is clothed by its event horizon. The horizon protects the rest of the universe from the madness of the singularity. It is a one-way wall. Information goes in, but the breakdown of physics at the center never comes out. But a naked singularity has no wall. The point of infinite density, infinite curvature, and broken laws is exposed to the open universe. It is visible. It can interact with the rest of the world. If the electron is a black hole, it is a super-extremal black hole. It is a singularity that spins so fast and is charged so highly that it has stripped off its clothes and stands naked in the heart of the atom. This idea leads us to the work of the visionary physicist John Archibald Wheeler in the 1950s. Wheeler, who coined the term black hole, proposed a concept called the Geon. He wondered if particles like electrons weren't solid balls of matter at all, but rather bundles of electromagnetic energy held together by their own gravity. He imagined light curving around itself so tightly that it formed a knot, a trap for energy. To Wheeler, mass without mass was possible. The electron could be a construct of pure geometry, a tiny tornado in space-time. In this view, there is no hard core at the center. There is only the field, twisted into a shape that looks like a particle. The touch you feel is just the edge of the tornado. But if the electron is a naked singularity, why doesn't it destroy the universe? Why doesn't it suck in everything around it? The answer lies again in that immense charge. The gravity of the electron might be trying to pull things in, but the electricity is pushing them away with vastly more power. The singularity is shielded not by an event horizon, but by a wall of repulsion. It is a repulsive singularity at close ranges. This is why atoms don't collapse. The electric force is the bodyguard of the nucleus, keeping the electron at bay. And the electric force of the electron is the bodyguard of its own core, keeping the universe at bay. There is another possibility, one that arises from the marriage of quantum mechanics and gravity: string theory. String theory was invented precisely to solve this problem of the point particle. It says that if we could zoom into the Planck scale, that pixelated basement of reality, we would see that the electron is not a point, and it is not a black hole. It is a vibrating loop of energy. This loop has a finite size, around the Planck length, so it avoids the problem of infinite density. It is small, but it is not zero. It has tension. It can vibrate. And in a beautiful symmetry, string theory suggests that a black hole and an elementary particle might be two sides of the same coin. A black hole is just a very heavy, very excited string. An electron is a very light, very calm string. They are made of the same fundamental stuff. As the physicist Leonard Susskind suggested, perhaps we can dial a black hole down until it becomes an electron, or dial an electron up until it becomes a black hole. They are phases of the same substance. So, where does this leave us in our search for the core? We are standing on the edge of a cliff. We have looked down and seen that the point of the electron is a place where space and time might be ripped apart. It is a place where the smooth fabric of Einstein's universe is punctured by a needle of infinite charge. Whether it is a naked singularity, a subplanckian ghost, or a vibrating string, one thing is clear: the inside of an electron is not space as we know it. It is a defect in the geometry of the world. Imagine for a moment that every electron in your fingernail is a tiny door to a place where time stops, a place where the rules of cause and effect break down. You are carrying trillions of these doors with you wherever you go. You are a walking collection of singularities. The only reason you exist as a coherent human being is that these singularities are balanced, tamed, and locked in a dance by the forces of quantum mechanics. The core is there, but it is forbidden. It is a place we can calculate, but never visit. This perspective changes the feeling of the world around us. We usually think of empty space as the boring part, and matter as the solid part. But if electrons are just knots in space-time or naked singularities, then matter is actually the most unstable, extreme part of the universe. It is the vacuum that is calm. Matter is the distortion. Matter is the flaw in the glass. When you look at a star, you're looking at a massive collection of these flaws shining in the darkness. In the next chapter, we will turn our gaze from the gravity of the core to the spin of the surface. We mentioned earlier that the electron spins, but not like a top. This spin is one of the most baffling properties in all of physics. It is the reason magnets stick to your fridge. It is the reason MRI machines can see inside your brain. But if the electron is a point, How can it spin? We will discover that this rotation requires the electron to turn around twice just to get back to where it started. We will explore the mathematics of Spinors, and we will ask if the spin of the electron is actually a signal that it is connected to a higher dimension, a rotation not in space, but in a direction we cannot point to. For now, let us rest with the vertiginous thought that we are made of monsters. We are built from tiny black holes that have been stripped of their horizons, tamed by charge, and woven into the delicate tapestry of life. The fact that such extreme entities can come together to create the softness of a petal or the warmth of a hand is perhaps the greatest miracle of all. If you hold a ball in your hand and rotate it 360 degrees, it returns to exactly the way it was. The label that was facing you is facing you again. The light hits it in the same way. The world has completed a full circle, and the object has reset. This is the logic of our daily lives. It is the geometry of the familiar. A circle is a circle. A turn is a turn. But if you were to hold an electron in your hand, assuming you could hold a ghost, and you rotated it 360 degrees, it would not be the same. It would be different. In the strange, twisted geometry of the quantum world, a single turn only gets you halfway home. To return an electron to its original state, to make it truly look like itself again, you must rotate it 720 degrees. You must turn it around twice. This is the mystery of spin, and it suggests that the electron is connected to the universe in a way that our three-dimensional minds can barely comprehend. It suggests that the electron is tethered to a deeper, hidden reality. We have spent our journey peeling back the layers of the electron's size and structure. We have looked at the cloud, the point, and the vacuum. Now we must look at its motion. But just as the point was not really a dot, the spin is not really a rotation. When physicists first discovered that electrons had angular momentum, they naturally imagined them as tiny spinning tops. It was a beautiful, intuitive idea. The Earth spins on its axis as it orbits the Sun. Why shouldn't the electron spin on its axis as it orbits the nucleus? It seemed to complete the harmony of nature. But as we touched upon earlier, this mechanical view falls apart the moment you look at the math. For a point of zero size to have the angular momentum we measure, it would have to spin infinitely fast. Its surface, which doesn't exist, would have to move faster than light. So, the word spin is a metaphor, a placeholder for a property that has no equivalent in our human world. It is an intrinsic form of angular momentum, a rotation that is built into the very identity of the particle, yet requires no actual physical turning. Before we try to visualize this impossible motion, I would like to take a moment to welcome any new travelers who have joined us. We are exploring the fundamental building blocks of reality, trying to find the poetry in the physics. If this quiet investigation resonates with you, please subscribe to the channel and join our community. I am Theodore, the researcher, and your support allows me to continue these deep dives into the unknown. Thank you for being here. The story of how we discovered this invisible rotation takes us to a smoky laboratory in Frankfurt, Germany, in the year 1922. Two physicists, Otto Stern and Walter Gerlach devised an experiment to see if the quantum world was truly quantized. They heated silver in a furnace until it vaporized, shooting a beam of silver atoms through a vacuum. They passed this beam through a strong, uneven magnetic field. They knew that if the electrons in the silver atoms were spinning like random little tops, their axes would be pointing in all different directions. Some would be pointing up, some down, some sideways, some at a 45-degree angle. As the beam passed through the magnet, these random spins should have been deflected by random amounts. The result should have been a smear of silver on the detector plate, a continuous vertical line fading out at the ends. But nature had a surprise waiting for them. Legend has it that Otto Stern was a cigar smoker, and the cheap sulfur in his cigar smoke reacted with the silver on the glass plate, turning it black and making the result visible. When they looked at the plate, they did not see a smear. They saw two distinct, sharp lips. The beam had split in two. Half the atoms went up, half the atoms went down. There was nothing in between. No atom went sideways. No atom went slightly up. This was the discovery of spin quantization. It meant that the electron's spin is binary. It is essentially a switch. When you measure it along any axis, the electron is forced to choose, I am spin up, or I am spin down. There is no middle ground. The universe does not allow the electron to be sort of spinning. It is an all-or-nothing property. This binary nature is the bedrock of the universe's structure. It is the bit of the quantum computer that is our reality. But the profound strangeness lies in the mathematics describing this state. To explain why the electron behaves this way, the great physicist Paul Dirac had to invent a new kind of mathematical object called a spinor. A vector is like an arrow. It points in a direction. If you turn an arrow 360 degrees, it points in the same direction. A spinor is more complex. It tracks not just the direction, but the entanglement of the object with the space around it. Imagine a coffee cup resting on the palm of your hand. Now, imagine there are elastic bands attached to the cup, stretching out to the walls of the room. If you rotate your hand and the cup 360 degrees, your arm will be twisted. The elastic bands will be wrapped around the cup. You are back to the start in terms of position. The cup is facing you, but you are not back to the start in terms of the system. There is tension. The state has changed. To relieve the tension, to untwist your arm and the bands without spilling the coffee, you must continue rotating the cup another 360 degrees in the same direction. You have to pass your arm under your elbow, performing a complex motion that brings you back to the true beginning, a total rotation of 720 degrees. This plate trick, or belt trick, is the closest analogy we have to what an electron is. It suggests that the electron is not an isolated object floating in a void. It suggests that the electron is tethered to the fabric of space-time. It has a tail, or a connection, that gets twisted as it moves. When an electron rotates once, it essentially twists space around itself. It enters a state of negative phase. It is the evil twin of its original self. It takes a second full rotation to untangle that twist and return to the positive phase. This means the electron perceives a larger geometry than we do. We live in a world of circles. The electron lives in a world of double circles. It implies that the core of the electron is plugged into a layer of reality that requires a longer path to traverse. This 720-degree symmetry is not just a mathematical curiosity. It is the reason matter is stable. It is deeply connected to the Pauli exclusion principle we discussed earlier. Particles that have this property, spin 1-2 particles, are the ones that refuse to share space. Because they have to turn twice to reset, their wave functions interfere with each other in a way that creates repulsion. If electrons were simple, 360-degree particles, they would all collapse into the same state, and you would dissolve into a puddle of light. Your solidity is a direct consequence of the electron's need to perform this double dance. But let us look at the consequences of this spin in our everyday world. You might think this is all abstract theory, but you interact with electron spin every time you walk into your kitchen. Look at the magnets on your refrigerator holding up a grocery list or a photograph. What is magnetism? We are taught that it is a force. But where does it come from? It comes from the spin. In most materials, electrons are paired up. One spins up, one spins down, and their magnetic fields cancel each other out. They are a balanced couple, silent and neutral. But in certain materials like iron, the electrons are lonely. They are unpaired. And under the right conditions, they all decide to spin in the same direction. They synchronize. Trillions upon trillions of tiny quantum spins align, their axes pointing the same way. The result is a macroscopic force that can pick up a car or hold a drawing to a door. A magnet is simply a window into the quantum world. It is one of the few places where we can feel the raw power of electron spin with our own hands. When you feel two magnets pushing apart, you are feeling the collective resistance of the electron's rotation. This connection between the microscopic spin and the macroscopic force leads us to wonder about the core again. If the spin creates a magnetic field and the electron is a point, then the electron is a tiny bar magnet. But a magnet has a north pole and a south pole. If you cut a magnet in half, you get two smaller magnets. If you keep cutting, eventually you get down to the atom and then to the electron. Does the electron have a north pole and a south pole? Yes, it does. But can you cut it? No. The electron is a monopole of mass, but a dipole of magnetism. It is the smallest possible magnet. This dipolar nature implies a directionality, an axis. How can a point have an axis? This brings us back to the idea that the electron might be a gateway to higher dimensions. In string theory, the spin is interpreted as a vibration of the string in a dimension we cannot see. The string is not spinning in our 3 dimensions. It is undulating in the 5th or 6th dimension. The energy of that undulation projects into our world as angular momentum. So, when we ask, what is hidden in the core, the answer might be a dimension. The core is the anchor point for a geometry that extends perpendicular to reality. Think of a flat, 2-dimensional creature living on a sheet of paper. If you stick a pencil through the paper and spin it, the creature sees a dot that somehow has energy. It cannot see the length of the pencil or the hand turning it. It just sees the spin as a mysterious property of the dot. We might be that two-dimensional creature. The electron might be the tip of a multi-dimensional pencil, and its spin is the evidence of a rotation happening in a bulk universe that surrounds our brain. There is also a deep connection between spin and time. The fact that the electron needs 720 degrees to reset suggests it has a memory. It knows that it has turned once. A simple ball does not know it has turned once. It looks identical, but the electron knows. It carries the history of its rotation in its phase. This suggests that the electron is not a simple object that exists only in the present moment. It is an object that trails its history behind it, entangled with its own past path. As we visualize this, the atom becomes a much more dynamic place. It is not just clouds and points. It is a symphony of spinning entities, twisting space around them, locking into binary states of up and down, aligning to create forces, and dancing a double-loop geometry that defies our intuition. The silence of the core is actually a humming, rotating frequency. And yet, despite all this, the electron remains a fermion. It remains solitary. Its spin is what separates it from the bosons, the particles of light and force. Bosons have integer spin, 0, 1, 2. They are 360-degree particles. They like to crowd together. They can occupy the same space. Lasers are made of bosons clumping together. But the electron, with its half-integer spin, stands apart. It is the spin that makes it matter, literally. Matter is made of fermions. Energy is made of bosons. The spin is the defining line between the stuff you can touch and the stuff that lets you see. So, what is hidden in the core? A knot in the geometry of space, a tether to a higher dimension, a memory of rotation, a magnetic heart that can never be divided. The electron is a tiny gyroscope that stabilizes the universe. Without its specific, peculiar, half-integer spin, the complex structures of life, DNA, proteins, stars, could not exist. We are here because the electron refuses to turn just once. We are here because it demands the full 720-degree journey. In the next chapter, we will venture into an even stranger realm. We will look at what happens when you reverse the spin, reverse the charge, and reverse time itself. We will talk about the mirror image of the electron, the positron. We will discuss the theory that suggests there might only be one electron in the entire universe, moving back and forth in time, weaving the tapestry of reality all by itself. We will ask if the core of the electron is actually a tunnel through time. For now, try to imagine that double turn. Close your eyes and visualize an object that changes when you turn it all the way around and only returns to normal when you turn it again. It is a dizzying thought. It breaks the logic of the circle, but it is the logic of your existence. You are built of these twisting, remembering spin-half ghosts, anchored to a reality deeper than the one you can see. If every electron is an identical ghost, indistinguishable from any other electron in the universe, then we must confront a possibility that sounds like a hallucination, but was proposed by some of the greatest minds in physics. In 1940, a young Richard Feynman received a phone call from his mentor, John Wheeler. Wheeler, with the excitement of a man who had seen behind the curtain of reality, said, "Feynman, I know why all electrons have the same charge and the same mass. Feynman asked how, and Wheeler replied, because they are all the same electron. This is the one-electron universe hypothesis. It suggests that what we perceive as trillions of separate particles are actually just different segments of a single electron's path, weaving back and forth through time like a needle through a fabric. To understand this, we must look at the electron's mirror image, the dark twin that lives in the shadows of the subatomic world, the positron. In the year 1928, Paul Dirac was attempting to combine quantum mechanics with Einstein's special relativity. He created an equation, now called the Dirac equation, that described the electron with breathtaking accuracy. But the equation had a strange quirk. Just like the equation Gatkentus 4 dos has two solutions, 2 dos solid and 2 dos, Dirac's equation had two sets of solutions. One described the electron we know. The other described a particle with the same mass, but a positive charge. At first, Dirac thought this was a mathematical error. But in 1932, this anti-electron was discovered in a cloud chamber. It was named the positron. It was the first evidence of antimatter. Before we dive into the time-traveling implications of this discovery, I want to welcome you back to our sanctuary of thought. If these explorations of the deep architecture of the cosmos bring you peace and insight, please subscribe to the channel. I am Theodore, the researcher, and it is my mission to guide you through these layers of reality with both scientific rigor and a sense of wonder. Your support allows us to keep the light of curiosity burning. Thank you. What is a positron? On the surface, it is just an electron with a positive charge. When an electron and a positron meet, they annihilate in a burst of pure energy, returning to the vacuum from which they came. But in the mathematics of physics, there is a deeper symmetry. According to the CPT theorem, charge, parity, and time, reversing the charge of a particle is mathematically identical to reversing its direction in time. This led Feynman to a startling realization. A positron is simply an electron moving backwards from the future into the past. Imagine a single electron starting at the beginning of time. It moves forward, experiencing the universe, until it reaches a point in the far future where it is scattered or diverted. At that moment, it turns around and heads back toward the Big Bang. As it moves backward through time, its negative charge appears to us as a positive charge. It looks like a positron. When it reaches the beginning of time, it turns around again and moves forward once more. In this view, the annihilation of an electron and a positron is not the death of two particles, but a single particle reaching a U-turn in time. One part of the path is moving forward, and the other part is moving backward. If this is true, then the core of the electron is not a place in space, but a moment in time. The electron is a world line, a single thread that crisscrosses the history of the universe millions of times. Every electron in your body, every electron in the heart of the sun, and every electron in the furthest galaxy is the exact same entity, appearing at different locations because it is intersecting our now at different points in its long temporal journey. This would explain why every electron is perfectly identical. They are not copies, but the original, seen over and over again. However, there is a flaw in Wheeler's beautiful idea. If there were only one electron weaving back and forth, there should be an equal number of electrons and positrons in the universe, one for every forward path and one for every backward path. But our universe is overwhelmingly made of matter. Positrons are rare, found only in high-energy collisions or radioactive decay. While the one-electron theory might not be literally true in its simplest form, it revealed a fundamental truth. Antimatter is the key to understanding the temporal nature of the subatomic world. This brings us to the core of the mystery. If an electron can be viewed as a particle moving through time, then the inside of the electron is the history of that movement. We mentioned earlier that the electron is a point with zero size. But if you think of it as a string or a path, its extension is not in space, but in time. The electron possesses mass and charge because it is dragging its temporal history with it. It is a knot in time just as much as it is a knot in space. Think of a movie film. If you look at a single frame, you see a static image of a person. That is the electron as a point. But the person only has meaning and weight because of the frames that came before and the frames that come after. The reality of the person is the whole film. Physics suggests that the electron we measure today is entangled with its future self and its past self. This is why it can remember its spin, as we discussed in the previous chapter. It is not just a point in the present. It is a segment of a cosmic thread. In modern quantum field theory, this is described as the propagator. It is a mathematical function that describes how an electron moves from point A to point B. Crucially, the math requires us to include paths that move backward in time and paths that exceed the speed of light. These virtual paths cancel each other out in the macroscopic world, but at the scale of the electron's core, they are the reality. The electron is a sum of all possible histories, a blurring of past and future. What if the core of the electron is actually a wormhole? Some theorists have proposed that an electron and a positron are actually the two ends of a microscopic Einstein-Rosen bridge, a tunnel through space-time. Instead of a particle with a charge, you have a mouth of a wormhole where the electric field lines enter and another mouth where they exit. The charge is just the direction of the flow through the tunnel. This would mean that the inside of an electron is not a place, but a bridge to somewhere else, perhaps to another part of the universe, or perhaps to the antimatter twin of our own cosmos. This Wheeler-Feynman perspective forces us to abandon our traditional view of objects. We are used to things having an inside and an outside because we live in 3 dimensions. But the electron exists in at least 4. Its core is the point where the 4th dimension, time, is pinched or twisted. When you feel the weight of your own body, you are feeling the resistance of a single, ancient thread as it is woven through the loom of the present moment. As we look at the positron, the mirror ghost, we see the profound balance of the universe. For every action, there is a reaction. For every electron, there is a potential positron. The vacuum is a graveyard of these threads, waiting for enough energy to pull a loop out into the light. The annihilation we see in PET scans in hospitals, where positrons are used to detect cancer, is a practical application of this time symmetry. We are using the backward-moving ghosts to see inside the human body. So, what is hidden in the core? A temporal loop, a bridge to the future, a memory of the Big Bang. The electron is a traveler that has seen everything and will see everything. It is the ultimate survivor, existing in a state where beginning and end are just different directions on a map. In the next chapter, we will leave the realm of time and return to the realm of flavor. We will discover that the electron has cousins, the muon and the tau. They are identical to the electron in every way, except they are much heavier and they die almost instantly. We will ask the famous question, who ordered that? We will explore why nature needs 3 versions of the same particle and what this tells us about the code hidden in the core. For now, reflect on the idea that you are made of time. Every electron in your heart has potentially traveled to the end of the universe and back again, just to be here with you right now. You are not a collection of dots. You are a tapestry of ancient, eternal threads, woven together in a fleeting, beautiful pattern. If the universe were a musical composition, the electron would be its most fundamental and recurring note. It is a pure, clear sound that builds the harmony of atoms. But in the 20th century, physicists discovered that this note has echoes. They found that the electron is not a solitary masterpiece, but part of a family of 3. These are the 3 flavors of the electron we know, the muon, and the tau. To understand what is hidden in the core of the electron, we must look at these mysterious siblings, for they are identical in every way. Same charge, same spin, same point-like nature, except for their mass. They are like 3 Russian nesting dolls, each one significantly heavier than the last. This discovery led the Nobel laureate I. Rabi to famously ask, who ordered that? The muon was the first to be discovered, found in the high-energy showers of cosmic rays hitting our atmosphere. It is essentially a fat electron, about 200 times more massive than its smaller sibling. Then came the tau, a true heavyweight, nearly 3,500 times more massive than the electron. Imagine 3 identical cars, one made of aluminum, one made of iron, and one made of solid lead. They look the same, they drive the same, but their weight is vastly different. Why does nature need 3 versions of the same particle? Why is the electron the only one that is stable, while the muon and tau decay into lighter particles in the blink of an eye? Before we ponder these heavier ghosts, I would like to welcome you back to our shared exploration of the deep cosmos. If you find solace in these quiet mysteries and value the pursuit of fundamental truths, please subscribe to the channel. I am Theodore, the researcher, and it is my mission to translate the rigorous data of our universe into a space of contemplative wonder. Your support is the energy that allows us to keep looking further. Thank you for being a part of this journey. The existence of these cousins tells us something profound about the code hidden in the core of the electron. If the electron were truly a fundamental, indivisible point with no internal structure, it would be difficult to explain why it has heavier versions. In any other area of science, if you have 3 objects with identical properties but different masses, you assume they are made of the same internal stuff, arranged in different ways. This suggests that there might be a subquantum level of reality, a world of particles even smaller than the electron, perhaps called preons. According to this theory, the electron is a specific combination of these preons, and the muon and tau are just more energetic, excited states of that same combination. However, we have never seen a preon. We have smashed electrons and muons together at energies that would rip a proton into pieces, and they still appear as solid, structureless points. This brings us back to the mystery of mass. Why do these particles weigh what they do? The answer lies in the way the core of the electron interacts with the most famous field in physics, the Higgs field. Imagine the universe is filled with a thick, invisible molasses that touches everything. This is the Higgs field. As particles move through this field, they experience a kind of drag, and that drag is what we perceive as mass. The electron is like a sleek, aerodynamic fish that slips through the molasses with very little resistance, making it light and nimble. The muon is like a larger swimmer that feels more friction. The tau is like a massive ship that the field clings to with immense strength. But why does the Higgs field stick to the tau more than the electron? The core of the electron must contain a specific value, a coupling constant, that determines its relationship with the Higgs field. This value is one of the fundamental constants of nature, yet we have no idea where it comes from. It is as if the electron has a serial number written in its heart that tells the universe how heavy it should be. If that number were slightly different, the entire structure of the universe would change. This leads us to the concept of generations. In the standard model of particle physics, matter is organized into 3 generations. The first generation, the electron, the up quark, and the down quark, builds the world we see, atoms, planets, and people. The second and third generations seem to exist only in the extreme environments of the early universe, or in our particle colliders. They are the dark matter of the particle zoo, existing as heavy, unstable ghosts. Could it be that the electron's core is a repeating pattern? Some theories suggest that the 3 generations are like the harmonics on a violin string. The electron is the bass note, the muon is the first overtone, and the tau is the second. This would mean that the inside of an electron is not a thing, but a frequency. The point-like nature we measure is just the node of the vibration where the energy is most concentrated. As we look at the muon and the tau, we see the electron's mortality. The muon lives for only 2 millionths of a second before it decays. The tau lives for even less, a mere fraction of a trillionth of a second. They are fleeting flashes of existence. Yet they are essential to the mathematical consistency of the universe. Without these heavier siblings, the equations that describe the weak nuclear force would break down. The universe needs the fat versions of the electron to stay balanced, even if they are never used to build in a single stable atom. Think about the implications of this. We are made of the light generation, the stable, long-lived survivors. But we are part of a larger family tree of matter that includes giants and phantoms we can barely fathom. The core of the electron is a mirror that reflects the existence of these heavier worlds. It carries the DNA of the entire 3-generation system within its point-like heart. What if there is a 4th generation or a 5th? Some physicists are searching for even heavier versions of the electron, particles so massive they would have only existed in the first billionth of a second after the Big Bang. If they exist, they would be hidden even deeper in the Higgs molasses. their cores tied even more tightly to the fabric of reality. As we end this chapter, I want you to visualize the electron not as a lonely dot, but as a member of a cosmic trinity. It is the stable anchor of a family that stretches into the extreme. Every time an electron in your body moves, it is acting according to the same code that governs the heavy tau in a distant supernova. The flavor of the electron is the melody of the universe, played in 3 different octaves. In the next chapter, we will bring all these threads together. We will ask the ultimate question. If we cannot see inside the electron, and if it has no size, is it possible that the electron is the only thing that is real? We will explore the idea of the universal field, and we will confront the possibility that the electron is a holographic projection, a piece of information stored on the boundary of the universe, appearing to us as a particle in 3 dimensions. For now, feel the solidity of your own body once more. You are built from the first generation of matter, the survivors of a violent cosmic history. You are the bass note of the symphony. The electron in your heart is a perfect, ancient entity, identical to every other, yet carrying the secret of its heavier siblings in a core that remains, for now, silent and closed. In our final descent into the heart of the electron, we must confront a possibility that challenges the very nature of what we consider to be real. We have searched for a core, a physical center, a tiny seed inside the fruit. We have looked for gears, for strings, for black holes, and for higher dimensions. But what if the reason we cannot find the inside of an electron is that the electron does not have an inside? What if the electron is not an object at all, but a piece of information? This is the holographic principle, a theory that suggests the entire 3-dimensional universe, including the trillions of electrons in your body, is actually a projection of data stored on a flat 2-dimensional surface at the very edge of the cosmos. For over a century, we have treated the electron as a point particle with no spatial extent. We have smashed them together at nearly the speed of light and found no internal structure, no smaller parts, and no radius. In the language of the Standard Model, the electron is a fundamental building block, a bass note in the symphony of matter. But, as we have seen, this point particle carries immense properties: mass, charge, spin, and a connection to heavier flavors like the muon and the tau. How can a 0-dimensional coordinate hold so much complexity? Before we reach the end of our journey, I would like to welcome you one last time to this space of reflection. If these explorations of the subatomic and the celestial have expanded your perspective, please subscribe to the channel and leave a like. I am Theodore, the researcher, and it has been my honor to be your guide through these layers of existence. Your support is what allows us to keep the light of inquiry alive in the vast darkness of the unknown. Thank you for traveling with me. The holographic principle arises from the study of black holes, the very monsters we suspected might live at the electron's core. Scientists discovered that the information content of a black hole is not determined by its volume, but by its surface area, the event horizon. This suggests that at the most fundamental level, the universe is not made of stuff, but of bits. If the electron is indeed a naked singularity or a sub-Planckian knot, then its entire identity all its charge, all its mass, and all its history, could be encoded on a distant boundary. The core we have been chasing is not a place. It is the source code of the projection. This realization leads to a profound sense of unity. We have seen that every electron is identical, indistinguishable from any other. If we are all holographic projections, then the separateness of particles is an illusion created by our three-dimensional perspective. The electron in a distant galaxy and the electron in your own eye are just different pixels of the same universal field. We are not observers of a universe made of parts. We are participants in a single, vast, and interconnected process. As we conclude our search for what is hidden in the core of an electron, we find ourselves returning to the beginning. We began with the sensation of touch, the electromagnetic repulsion that prevents us from ever truly making contact. We found that this repulsion is governed by the Pauli exclusion principle, a law of loneliness that keeps atoms from collapsing and allows the complexity of life to emerge. We discovered that the electron is a guardian of the void, a frantic ghost that creates solidity through its own uncertainty. So, what is hidden in the core? Perhaps it is the universe's most profound secret, that there is no inside, because everything is connected. The electron is a point, because it is a focus of energy, a knot in the field, a ripple in the ocean of the vacuum. It is a traveler through time, and a bridge to higher dimensions. It is a tiny, ancient entity that has existed since the first billionth of a second after the Big Bang, carrying the history of the cosmos in its silent, massless heart. The search for the core of the electron is ultimately a search for ourselves. We are made of star stuff, forged in the nuclear furnaces of ancient suns, and held together by the tireless dance of these invisible ghosts. When you look at your hand, you are looking at a masterpiece of quantum engineering. You are a walking paradox of infinite potential and finite form. The mystery of the electron is your mystery. Thank you for joining me on this journey. The universe is far deeper and more beautiful than our eyes can see, but our minds have been given the gift of wonder. No matter how small the particle or how vast the galaxy, the quest for understanding never truly ends. It is an infinite journey, and I am grateful to have shared this segment of it with you. Until our next exploration, keep looking inward, keep looking upward, and never stop wondering. I am Theodore, the researcher, and the cosmos is waiting for us to ask the next question. In our final descent into the heart of the electron, we must confront a possibility that challenges the very nature of what we consider to be real. We have searched for a core, a physical center, a tiny seed inside the fruit. We have looked for gears, for strings, for black holes, and for higher dimensions. But what if the reason we cannot find the inside of an electron is that the electron does not have an inside? What if the electron is not an object at all, but a piece of information? This is the holographic principle, a theory that suggests the entire three-dimensional universe, including the trillions of electrons in your body, is actually a projection of data stored on a flat, two-dimensional surface at the very edge of the cosmos. For over a century, we have treated the electron as a point particle, with no spatial extent. We have smashed them together at nearly the speed of light, and found no internal structure, no smaller parts, and no radius. In the language of the Standard Model, the electron is a fundamental building block, a bass note in the symphony of matter. But, as we have seen, this point particle carries immense properties, mass, charge, spin, and a connection to heavier flavors like the muon and the tau. How can a zero-dimensional coordinate hold so much complexity? Before we reach the end of our journey, I would like to welcome you one last time to this space of reflection. If these explorations of the subatomic and the celestial have expanded your perspective, please subscribe to the channel and leave a like. I am Theodore, the researcher, and it has been my honor to be your guide through these layers of existence. Your support is what allows us to keep the light of inquiry alive in the vast darkness of the unknown. Thank you for traveling with me. The holographic principle arises from the study of black holes, the very monsters we suspected might live at the electron's core. Scientists discovered that the information content of a black hole is not determined by its volume, but by its surface area, the event horizon. This suggests that at the most fundamental level, the universe is not made of stuff, but of bits. If the electron is indeed a naked singularity, or a subplanckian knot, then its entire identity, all its charge, all its mass, and all its history, could be encoded on a distant boundary. The core we have been chasing is not a place. It is the source code of the projection. This realization leads to a profound sense of unity. We have seen that every electron is identical, indistinguishable from any other. If we are all holographic projections, then the separateness of particles is an illusion created by our three-dimensional perspective. The electron in a distant galaxy and the electron in your own eye are just different pixels of the same universal field. We are not observers of a universe made of parts. We are participants in a single, vast, and interconnected process. As we conclude our search for what is hidden in the core of an electron, we find ourselves returning to the beginning. We began with the sensation of touch, the electromagnetic repulsion that prevents us from ever truly making contact. We found that this repulsion is governed by the exclusion principle, a law of loneliness that keeps atoms from collapsing and allows the complexity of life to emerge. We discovered that the electron is a guardian of the void, a frantic ghost that creates solidity through its own uncertainty. So, what is hidden in the core? Perhaps it is the universe's most profound secret, that there is no inside because everything is connected. The electron is a point because it is a focus of energy, a knot in the field, a ripple in the ocean of the vacuum. It is a traveler through time and a bridge to higher dimensions. It is a tiny, ancient entity that has existed since the first billionth of a second after the Big Bang, carrying the history of the cosmos in its silent, massless heart. The search for the core of the electron is ultimately a search for ourselves. We are made of star stuff, forged in the nuclear furnaces of ancient suns, and held together by the tireless dance of these invisible ghosts. When you look at your hand, you are looking at a masterpiece of quantum engineering. You are a walking paradox of infinite potential and finite form. The mystery of the electron is your mystery. Thank you for joining me on this journey. The universe is far deeper and more beautiful than our eyes can see, But our minds have been given the gift of wonder. No matter how small the particle or how vast the galaxy, the quest for understanding never truly ends. It is an infinite journey, and I am grateful to have shared this segment of it with you. Until our next exploration, keep looking inward, keep looking upward, and never stop wondering. I am Theodore, the researcher, and the cosmos is waiting for us to ask the next question.